Hello folks, so this is Cambridge Pre-University Certificate 2012 May-June paper 1 and the question number is 19. It is concerned with the chapter current electricity, and as usual it is useful for we CAIE A-level people also. It says that a circuit is shown, circuit as shown like this. So it has got internal resistance, so that's why it has been used inside a dotted box. When 100 coulomb flows around the circuit, 100 coulomb charge flows around the circuit, 120 joules of electric energy is dissipated in resistor R. So here it is 120 joules of energy, and 20 joules in the battery's internal resistance. So here it is 20 joules. Now with this data we have to find the EMF of the battery. I'm addressing this question because it is slightly unconventional, because in most of the cases the EMF is given by the knowledge of current, resistances, terminal PD, etc. But here we have only energy and charge. So let's first do this thing. So here it's 120 joules and here it's 20 joules. That means the cell had provided the energy provided by the cell, energy provided by the battery or cell. It was equal to sum of these energies. So that's equal to 120 plus 20 equal to 140 joules. So the cell or battery provided 140 joules energy provided. So now the EMF should be equal to total energy provided by the battery, per unit charge. So per unit charge. So it should be energy is equal to 140 joules and the magnitude of charge is equal to 100 coulomb. So it is equal to 1.4 volt. So 1.4 joule per coulomb actually, joule per coulomb, which becomes equal to 1.4 volt, which gives a choice D as the correct answer. So without current, without the value of resistances also we can find the value of EMF, because it follows from the very basic definition because EMF is equal to the amount of energy required to move 1 coulomb of charge throughout the circuit, and in case of a battery it is the converted form of chemical energy as well. So we are going through the basic definition to find the value of EMF in this case.